we want to start thinking about vectors mathematically and doing mathematical calculations with them, we have to start considering their components. So what is a vector component? Well, vector components essentially are something that tell you about the influence of a vector along a certain axis. And I'll explain that just by showing what I mean. If we draw two arrows on the x and the y-axis starting from the tail of this vector p, and we draw it to the edge of where the vector ends. So we kind of have this box, like so. Along the x-axis, it tells us something about how far this vector travels in the x direction and how far it travels in the y direction. So we call this px and py. So these two are the components of vector p. And there's two of them because we're in 2 dimensions. If you had 3 dimensions, you'd have 3 components and so on. But we can also describe in a more sophisticated way as px as the projection of p onto the x-axis. So to sum this up, px would be the x component of the vector p, and py would be the y component of the vector p. So what's the purpose of this? Why would we want to consider, break a vector down into these two components? Well, if you notice, these vector components allow us to express p in terms of right triangles. Right triangles, which allows us to use trigonometry. We can use some of the rules of trigonometry. So we've got 2 lengths, and then p, the magnitude of the vector p would be the hypotenuse, and then you can have an angle there to tell you the direction. So from this we can start building equations to help us do vector calculations. So I'm going to draw this out bigger. So we have some vector p, and then we've got an x component, or sorry, a y component and an x component. So let's start building some equations here. And we've got an angle here too, theta. So if you remember from trigonometry, some of the basic trigonometric functions, you've got sine, we'll say sine of theta, cosine of theta, and tangent of theta. So what are these? If you think about triangles, what are these? Well, sine, remember, is the opposite length over the hypotenuse. In this case, the opposite is the same as py, if you think about it this way. So in this case, sine of theta is py over the magnitude of p. So this would be the magnitude. Cosine would be the adjacent side over the hypotenuse. So you get px over the magnitude of p. And then tangent is the opposite over the the opposite over the adjacent side. So you get py over px. So here we have, just using basic trigonometry now, have defined 3 equations for calculating a few things. You can calculate the components, the x and y components, if you know both the magnitude of the vector and the angle it is at, so essentially the direction. And we also, you can calculate the magnitude of the vector if you know the angle and one of the components or both of the components. We can also find the angle that it is from any axis if we know the components and the magnitude of the vector. So we have equations here that are relating different variables that we want to find. And so note also that we have everything we need here to calculate a vector. So a vector is a magnitude and a direction. So we can find our magnitudes in these equations, and then we can find our direction through the angle it is. And so we have everything we need here to calculate vectors. Now let's do an example quickly so we can see it in practice. I'll draw a similar looking vector like so with a x component and a y component with an angle here. And let's say we're given, we know the angle to be 45 degrees, and we know the projection of x to be 4. And what we want to find is the magnitude of p. So how would we go about doing this? Well, we know the projection of x is 4, and we know that the angle is 45 degrees. So if we look back at our equations here, which equation here can we solve for the magnitude if we know the angle and we know the projection of x? The answer is this one here. So we can apply this equation above and say that we'll write it out. Cosine of theta equals px over the magnitude of p. We can solve for this p by multiplying over and then dividing out the cosine theta. So the magnitude of p is equal to the projection on x divided by cosine of theta. Then plugging our numbers in, you have 4 divided by cosine of 45. And that, having done the math ahead of time, comes out to be 2 square root of 2 in its exact form, or in decimal form, about 2.83. So that would be your magnitude of p. Now, one final thing is there are times when we know both, if we know both the x and the y component, and we want to find the magnitude, we can use a trusty old theorem, Pythagorean theorem, which says that the magnitude of p is equal to px squared plus py squared. You see it in this form. The magnitude of p squared is equal to px squared plus py squared. Or simply the magnitude of p is px squared plus py squared, the square root of that whole thing. And so that is actually the definition. Pythagorean theorem is the definition of the magnitude of a vector. So that is also an important equation. This plus the 3 equations that we found moments ago are 4 of the most important equations you will need to do to find vector components and do vector calculations. So I'm going to do some more examples on this in the following videos, but that's just a basic introduction to vector components.